All right. Now, continuing the data collection plan, how will you ensure consistency and stability, okay, of the data collection? And what is your plan for starting data collection? Okay, like when will you start collecting? Will you start collecting in the first shift, or when this product is running, or when this machine is on, etc., etc.? Okay, and how will the data be collected? For example, are you going to take when the product is coming continuously? Are you going to take 5 samples? Are you going to take 5 samples every half an hour or 1 hour, or what it is? Okay, so those things should be very, very clear. So what will you do to make sure the data collected at one point in time is comparable to the data collected at other times? Very, very important, right? That is, there is no bias that is being introduced in the way the data is collected. Bias in the sense that you have an inclination to actually write the data on what you think instead of what actually it is. You tend to favor some value, okay? And what is your plan for starting the data collection? Just how will you go about collecting the data? And this is thinking about how you will display the data. How will you present the data? Will help you to make sure that you're getting the right kind of data to answer the question that you have in your mind. Because ultimately, data is for decision making. Okay? And if you collect sufficient data and necessary data, correct data and complete data, then your decision would be correct. If you don't collect necessary data, if you don't collect sufficient data, if the data is not correct, if the data is not complete, then your decisions is not going to be 100% correct. Let's move further. The better that you are able to present the data, the faster that you are be able to make the decisions. For example, if it is presented in the form of graphs or visual representation, then you can take the decisions faster, right? In fact, in the graphical analysis of data, because there is something called descriptive statistics and there is something called graphical summary. Now, examples of data. Let's say a project team, simple, I'll give you a simple example. Okay, you're having a particular level of variation and that variation is called as a sigma level. Let's assume that, okay? Sigma level means whether it is 1 standard deviation variation or 2 standard deviation, we'll talk about standard deviation and all that, but how much it is varying, how much level of variation it is there, that is sigma level. Okay, level of variation. So that is called as a sigma level, and how to find out that sigma level is something that we will see. So the question is, in the order processing, all the company process some orders, right? Purchase orders. And there are errors during order processing. So you can ask these 2 questions. So this is what is a question we will ask. What are the most common errors during order processing? And what is our current error rate? Error rate is something, the rate at which we are producing these errors. Are they more frequent, less frequent? What is its occurrence? Okay, what is the frequency of occurrence? How frequently do you make these mistakes? Okay, this is called error rate. So simple questions, right? And now if you observe the common types of errors, the counts of different types of errors. For example, purchase order number is wrong. That is, if you take 100 purchase orders, probably 4 purchase orders where purchase order number is wrong. Okay, there are 2 orders where the tax, the supplier's tax details or GST details are wrong, or where the quantity entered is wrong, or probably the rates are the old rates that are wrong. So how many purchase orders with rates wrong? How many purchase orders with taxation details like GST wrong? How many purchase orders which has got a purchase order number itself is wrong? Yeah, product type is wrong, anything, right? And the number of errors per order. Suppose if I pick up 1 purchase order, in that order, have I made 3 mistakes or 5 mistakes or 10 mistakes in the order? Let us see one more example. Improve on-time delivery. Okay. For example, pizza delivery. Okay. Now, if you order pizza now, in how much time do you want? 10 minutes, 15 minutes, 20 minutes, 30 minutes? How many minutes do you want the pizza? So if you say improve this on-time delivery, the questions that we need to ask is, how long does it take for the pizza guy, for the pizza shop to process this order now? And what are the steps that consumes most time? Okay, which go quickest? Okay, so we should be able to say different activities and which process takes more time, which process takes less time. These are the questions we need to ask. The questions are very important. What accounts for the differences between the slow and fast steps? What are the causes? What are the reasons? Right? Now, let's see the data that we require for each of this data type. Okay. For example, how long does it take us to process an order? Now, cumulative time for the process order. Okay, so you can take 100 pizza deliveries and say the starting point from the time that the purchase order is given to the time that it was delivered to the house. Cumulative time for the order, processing an order, right from that to this, what is the total time that is taken? That is one type of data. Second, what steps consumes most time and which goes quickest? The time needed in each steps, time spent. That's why we say activity analysis, right? Cycle time analysis and things like that. Different types of analysis. Then what accounts for the differences between the slow and the fast steps? So the information on process conditions, because we are going into the depth of the other data that we are collecting, whether some product is raw material, for example, is kept near to you, or this thing, is he going too far to fetch something? Is he looking out for instructions to do that? So those are the process conditions information.